Good day. Tanner Dwight Tumalay from BS Packaging Engineering 1, and this is my lesson about basic integration, U-substitution, and integrating by parts. So let's have it. So in Calculus 1, we have differential calculus, diff and integral. So, okay. So what we'll do here is, um, first in differential we have x cubed. So here integral x cubed. So x cubed is just written here. So differential is, if we differentiate um, x cubed, have power rule. So simply put the exponent here. So 3x and subtract. So the main difference from differential and integral is subtraction and addition. So subtract 2 minus 1. So that, so it's equals to 3x squared. So that is the derivative of x3. So when it comes to integral, you'll have integral sign x3 and we'll put dx. So equal to, so the power rule of integral is like this. We'll have, I'll just adjust the camera here, right there. So you'll have x cubed, so x cubed. So here we subtract, but um, in integral you um, add 1. So but you divide the function by this, so 3 plus 1 dx. So you'll have um, x4 over 4. So dx will return. So always put in mind to put the constant or c. The c. So that is our answer. So let's have another example. So basic integration. So basic integration. So number 1 is integral of 3x to the 5th dx. So we'll have here 3x to the 5th. So it's equals to 3x. So what we're gonna do next? So we have the exponent plus 1 over 5 plus 1. Just copy the exponent, it's added by 1, 2, and make it also as your denominator. So you'll have dx. So it's equals to 3x6 over 6. So do not forget to add your constant plus c. But it is not our final answer. So we can divide it or transform it into a much easier or more convenient function. So 1/2 x to 6 plus c. So that's our final answer. So second example. So integral of x dx. So always remember that when it comes to square roots, there is always an imaginary 2. So some people can put 3, but ang number above 2 is always indicated. So there's an imaginary 2 right there. So you can also write this as 2x dx. So here, so we can transform square root of x into x 1/2 dx. So we continue. equals, so still power rule, x 1/2 plus 1 over 1/2 plus 1. Yes. So you can just, we can't put mixed fraction, like we cannot put mixed fraction, so we'll just use our basic maths, like, so we're gonna use x, so 1/2 plus 2 over 2, so it's equal to 1 over 1/2 plus 2 over 2, so it's equal to x 3 over 2 over 3 over 2, tapos plus c. So this is our answer. So next topic. So our next topic is integrating by substitution. So U-substitution. I hope that my camera sees this. Right there, U-substitution. So I'll try to put lights. So U-substitution. Number one example. Square root of 4x minus 6 dx. So when we use or do integrating by U-substitution, what we do here is the main trick in integral calculus is transforming certain functions into, or substituting, or transforming it into something easy, that is easier to work with. So U-substitution is one of the things that are tricks that you do to integrate certain functions. So you'll have here 4x minus 6. So we could turn it into, here it is, we can turn it into integral of 3x or 4x rather, 4x minus 6 and exponent of 1/2. So exponent of 1/2, this is 1/2. I'm sorry, my camera is not that good, so when you have 1/2, wait, it's not focusing. It's not focusing. But this is 1/2. So this case, it is very hard to integrate. So what we're gonna do is use the U. So U substitution. So U, let U be, which is what you're gonna do is choose the harder in function to, or the hardest part of the function to substitute U. So for me, I'll substitute 4x, and you'll have the derivative of U dtx is equals to 4, but I'm gonna multiply it by 4x squared of 4, 4x, so dx over 3, so like that. So another thing you'll find is your du, your dx. You have your du here, so you have your dx, so du, and 4, not 3. So du, so over 3 is equals, so dx, or dx is du over 3, or 3 du. So let's integrate. Have, so first term is u, just for x times 1/2, just like what we did here, so x 1/2 because of the square root. So we'll have u, so 1 u into 1 dx. So cool. So you put your du, so equals, oops, equals to u 1/2 du, du over, so this 4 should be 4. So I have 1/4 u 1/2 because of the square root. So should have dx, but the function we change in the x we change to u, so we can substitute. So we'll have 1/3. So you put the 1/4. I mean, so you put the 1/4 outside, okay, outside. So you have u 1/2 plus 2 over 2 over 1/2 plus 2 over 2 b. So we'll have 1/3 u 3 over 2 over 3 over 2 plus c. So we'll have 1/3. So we can, it's not our final answer yet, so you can put this 3 over 2 outside. So if you, the denominator is put outside, it will become reciprocal. So 1/3, let's enclose this, times u 3 over 2. So what we'll have is reciprocal of 1/3, 1/3. I'm sorry, I'm looking at my notes, so I am very confused. I'm sorry. It is 4 rather. I'm sorry. So we'll have 1/4. So we'll have reciprocal of 3 squared is 2/3. So we'll have 2/3. So here's plus c. So you still can, you still have u, and you still have, so here, so 1/4. So you'll have 1/4 u 3 over 2. Actually we don't have the same term here, so you can just put it back. So 2/3 plus c, 3 over 2, I mean. Let me see. So we have this c. So let's substitute back. Substitute back. Substitute back. So 1/4 times square of 4x 3 over 2. 3 over 2 plus c. Answer. So let's use now let's use U substitution again for example number 2. So this enclosed part is should be our U. So um, because it's much harder to integrate, so we have let U is equals to x squared minus 9. So let's just leave the exponent 4 right there. So du derivative u is 2x. So let's differentiate 2x. So we also have here, before I forget, is our du. So our dx is equals to du over 2x. So should have du dx here. So this transform our du here. So du over 2x. I mean our dx here is du over 2x. So um, start. So copy 2x. So u 4. So because we substitute x squared minus 9, so we'll have u fourth power here. So our dx, is du over 2x. So in this case, the idea of integrating is finding a easier and more convenient way when it comes to functions. So we can cancel here 2x. So we're left with u 4 over du. So in this case is much more easier, so we can substitute it back. But before we can substitute, we can integrate it first. So u4 plus 1 over 4 plus 1 du, so equals to u5 over 5. We have u5 over 5. So we have our constant. Never forget to add our constant. So we'll have u5 over 5 is not our final answer yet. So we'll have our substitution back. So substitute back. So substitute back the u. So u will be equal to x squared minus 9 to the 5th power over 5 plus c. So that is, let's see first if we can transform it into or simplify it. So in this case, we cannot. Let's see, we cannot. So this is our final answer. So next lesson, I have another paper here. So next is integration by parts. So integration by parts is a lot more. It is a lot more complicated. So let's see if we have this right space. You can see everything. Yes. So should adjust my camera a little bit. So okay. Um, Integration by parts. Um, um, is the formula here. So our formula is, let's see my screen. Part is uv is equals to uv minus integral of v. So that's so when it comes to integrating by parts, I'm gonna use this formula. So there is a trick or a hack, or it's not really a hack but a trick that is used by many mathematicians, and also I saw online is they use the term LIATE or liate. So LIATE um, um, stands for logarithms, inverse trigonometry, algebra, trigo, and exponent. So when it comes to integration by parts, instead of just only substituting by u, you also use v. So you can substitute u and v. So you must prioritize in this order for u. So u is if you have the logarithms, you must prioritize in this order. So in this case, we have logarithms here and an algebra here. So in this case, we'll use ln as u. So we'll have u, du, v, and dv. So we'll have, so logarithms was first. So ln x, x, and du is 1 over x dx, and v is x, and dv is v, dv. So I'm sorry, I timed it out. So okay. So again, here u is ln x, du is 1 over x dx, and v is x, and dv is 1 dx. So we can just simply put here 1, but and here is 1 over x, but we should indicate that it is a derivative. So let's try to solve. So we'll use this formula. So we'll have u times v. So ln x times x minus derivative of x, 1 over x dx. So in this case, we can cancel here x, x. So we'll have this x, multiply here. So x ln x minus derivative of 1 dx. So right here, we don't have any function to differentiate. So we can just simply put this as negative x. So x ln x minus x plus c, which is our constant. So this is our final answer. So next, so we have 2 e of x, 2x. So 2 to here, x, which is x, e of x, and e of the power of x. So our u is equals to x, our du is equals to 1 dx, because the numerical coefficient and exponent is 1, so 1 times 1 is 1, still 1, and x is terminated, so it's just 1 dx. So v is equals to d or e x. So as we know, um, derivatives of exponential to the x power of x is also ex, just but we put here dx. So we use this as v because if we can see here in our liate or liate, we can see that we use 2x because algebra comes first before exponential. So we start to solve. So ex dx equals 2ex 2x e dx is equals to, so I'm gonna transform this or this. So with the same formula, we'll use, so our x, so our 2x, I mean it's 2x, it should be 2x, I mean sorry, I forgot, this is 2x and it should be 2 dx, 2 dx. So what we're gonna do here is 2, so 2 use, so first is u times v, so this use changes the parenthesis, so u, which is u is 2x, so u is 2x times v, what is v, x minus ex, u v is ex, ex dx. So that's it. We just simply do see which is um first in the order, and we'll just substitute to the formula. So 2x ex minus ex plus c. That is our final answer. So that is all for my lesson. I hope you learned something, and thank you.